Okay.
But he was saying that it ain't no thing. He ain't got like no nipple on his like. It's just like what you said. Like refrigerators just don't do that no more. Like you can't charge.
Oh yeah, you can't. Once it's gone, it's gone.
Yeah,
even if
because they usually refrigerators don't have leaks in them.
Gotcha.
Have me a voltmeter.
All right, so I'm just telling you that's the difference. Until they 30 something, looking like they 80 something.
Yep. You know it.
All bent up in the bed somewhere, waking up with nothing to do with themselves.
With the ugly face. No, hell no, dog.
Even when I'm on my health shit, what the fuck is that, yo? And some of my niggas be listening, dog. The rest of them other niggas, man, niggas don't be listening.
I'm tired of teaching niggas these days.
Yeah.
So you see that?
Olive oil and fish oil. Family.
This is a continuity meter.
For your heart.
When these are together, that means it's continuity. It's important when you checking stuff.
Say it again.
It's a continuity meter. So this is when it's set for resistance or ohms. It usually has this little sign on it that looks like a sound wave. And once you put it on that and you touch these together, it rings out. And what that pretty much means is that something has continuity. Continuity means that it is connected. It's a continuous circle. Okay, that's important when you're checking for stuff, especially when you're checking to see if something is working the way it's supposed to. Prime example. I'm gonna start with this transformer. Where's the transformer at? It's right up there. No. Where's the transformer at? Oh, that's right in my face.
Yeah, I thought I wanted to do that.
So, on a transformer, some transformers are step-down transformers. Some transformers are step-up transformers. Step-down transformer means that it takes a higher voltage and makes it a lower voltage. Step-up transformers means it takes a lower voltage and makes it a higher voltage. This will be considered a step-down transformer. Now, this is one of those transformers that can be used for multiple voltages. It can step down multiple voltages versus just going from 120 to 24 volts. If you look at the transformer, the first thing you want to do is you want to identify the primary and the secondary. Primary is going to say PRI, secondary is going to say SEC. Primary, secondary means that it goes in, whatever it goes in is primary, whatever comes out is secondary. So if this was a step up transformer, the primary will be a lower voltage and the secondary will be a higher voltage. But because this is a step down transformer, the higher voltage which is the primary and the lower voltage is secondary. Primary voltage is either common. That means that you got to hook common up with each wire. You got to have something to bring the power back. Something takes the power out, something brings the power back. The thing that takes the power usually has the voltage in it, and the thing that brings the power back is usually a common or a neutral. In this particular instance, the common wire is, if you look right underneath of it, it is the white wire. So the white wire has to be hooked up no matter what. So you always got to have your white wire hooked up since it's the common wire. It is going to be the commonality between all the rest of these three wires and what they do. The next one is 120 volts. If you go down, that's the black wire. So if you had 120 volts that you was trying to step down to 24 volts, you will hook these two wires up. If you were trying to step down 208 volts to 24 volts, you will hook up the white wire and the red wire. If I was hooking up something that was 208 volts, stuff that runs off of 208 volts is like dryers, some wash machines, things like that run off of 208 volts. And you will hook these two wires up to step that down to 24 volts. And lastly, if you had something that was 240 volts that you were hooking up to and you were stepping it down to 24 volts, you will hook up these two wires right here. Okay, so this is a multi-phase transformer that can step down 120 volts, 208 volts, or 240 volts down to 24 volts. Now on the secondary side, that's what's coming out. and that is the yellow and the blue wire. And if you look here, it says blue and yellow is the 24 volt secondary side, which means that the voltage coming out of these are going to be 24 volts. It's going to go in high voltage, it's going to come out low voltage. That's how a transformer works. Okay, now what I have hooked up here is I have a transformer that is right now, if you watch, show 'em, it's connected to 120 volts because residential plugs are 120 volts. It's connected here. I have it spliced here. It's going to a yellow, it's going to a white and a black wire, which means it's going in 120 volt, 124 volt, 120 volts. And then I have it on this side coming out, and these are the secondary wires, and they're coming out 24 volts. And I have that hooked here. 24 voltage is considered low voltage, and low voltage is considered control voltage. Here I have a contactor. Contactors are found in air conditioning systems. In an air conditioning system, you have what's called a contactor. And if you were to look at your AC outside, you will have something that looks like this that has a white wire and a black wire. Sometimes it's a white wire. Sometimes it's a black wire with a white wire that has black tape on it. And the reason why that black tape is there is because it has voltage in it. This is a 240 volt circuit because 120 volts is coming in from this side, and 120 volts is also coming in from this side. And these are coming from the disconnect box. Now, this doesn't work or doesn't send voltage to this side unless that's pushed in. I don't know if you can see that, but that gets pushed in. Okay? Now, why is that important? Because the thing that pushes that in is not your finger, of course. It is the 24 volts that comes off your transformer. So when you go outside, you're also going to have 24 volts, or you're going to have wires connected to what's called the coil. The coil is this piece that's underneath of here. Inside of there, there's a wire that's wrapped up real tight, and when you put voltage to it, it creates a magnet effect. So what happens is when you take 24 volts and you put it right on the coil, it pulls in the contactor. See that? Do it again. Pulls in the contactor. So what happens? One more time. It pulls in the contactor. So with that contactor being pulled in, it sends voltage from here to here. So now the 120 volts that was only on this side is now coming out of this side. This is considered your line. That's the feed of the electricity. This is considered the load, whatever you're trying to control, coming off of the contactor. Okay, so that's pretty much how a contactor works. And if you just need something that runs off of 120 volts inside of the system, then you would only hook up to one of these sides because each of these sides holds 120 volts. If you need something that needs 240 volts to work, like a compressor or a condenser fan motor, then you need to hook up to both sides. 120 for this one, 120 for that one equals 240 volts. And that's how a contactor and a transformer works.